Welcome back to Mr. Vaughn's classroom. Before we get started on today's lesson, I'd like to ask you to please hit the subscribe button and give this video a thumbs up. Now, as we get started, we are in Unit 4 on functions, and this is Lesson 9, comparing graphs. This is the last lesson before the mid-Unit 4 test. The learning goal today is to compare graphs of functions to learn about the situations they represent. We have 3 learning targets today. As we go through the practice problems, please keep these 3 things in the front of your mind, and at the end of the lesson, if you don't feel comfortable making any of these 3 statements, please leave a comment below and I'll get back to you with clarification. The first learning target, I can compare the features of graphs of functions and explain what they mean in the situations represented. Learning target number 2, I can make sense of an equation of the form in terms of a situation and a graph and know how to find the solutions. And learning target number 3, I can make sense of statements about 2 or more functions when they are written in function notation. Our first glossary term is average rate of change. Remember that average rate of change simply means your slope. It is how much you're changing in the y direction divided by how much you are changing in the x direction. So you can pick any 2 points. On the top, you're going to take the second y value and subtract the first y value. And on the bottom, you're going to take the second x value and subtract the first x value. And this is going to give you your average rate of change or your slope. Our next glossary term is decreasing function. Simply put, a function is decreasing when it has a negative slope. When you see the function going down from left to right, as in the bolded part of the example at the bottom of this slide, or when you see that the y value is decreasing as the x value is increasing, that is when you have a decreasing function. We are referring to what the y value is doing as the x value is increasing. Our next glossary term is horizontal intercept. Remember, a capital H has that left to right line in the middle of the H. Your horizontal intercept is where your graph is crossing the x-axis, that side-to-side axis. And anytime you have a horizontal intercept, your y value is going to be 0. So your point pair will be some value for x and 0 for y. Our next term is increasing function. This is referring to the y value increasing as the x value is also increasing. So on a graph, as in the example at the bottom here, you can see that on that left side where they have bolded that line for the parabola, it's because the y value is increasing as the x value is increasing. Therefore, you have a positive slope and an increasing function. Our next glossary term is maximum. We are referring to the y value here. We are referring to the largest y value, either the overall maximum, meaning the largest y value on the graph as a whole, or we could be referring to a local maximum, which would be the biggest y value in a given domain of x values. The next glossary term is minimum, and this is the opposite of a maximum. Here we are looking at the smallest y value. Again, this could be the minimum for the whole graph, which would mean the smallest y value on the graph, or it could be a local minimum where we are taking a specific domain of x values and we're looking for the smallest y value within that domain of y values. And our last glossary term is vertical intercept. Remember, a capital V has two lines that are going up and down. So your vertical intercept is where you are crossing the y-axis, the axis that goes up and down. So your vertical intercept is your y-intercept, and if you're on that vertical axis, then your x value is always going to be 0. So a vertical intercept will have a point pair of 0 for the x and some number for the y. Now we can begin the practice problems for Unit 4, Lesson 9, Comparing Graphs. Functions r and d give the height in feet of a toy rocket and a drone t seconds after they are released. Here are the graphs of r for the rocket and d for the drone. Write each statement in function notation. So number 1, at 3 seconds, the toy rocket is higher than the drone. So what we know here is that 3 seconds will be the inputs. And remember, function notation is name, input in parentheses, equals output. This time they don't give us an output, so all we really have is that the toy rocket, so I want capital R for rocket, at 3 seconds is higher, that means greater than, the drone. The drone is capital D, and again, the input is going to be 3 seconds. So the function notation for number 1 is capital R of 3 is greater than capital D of 3. And we can see that right here. Capital R at 3 is this top red dot, and capital D at 3 is this bottom red dot. Number 2. At the start, the toy rocket is 25 feet above the ground. So I know that my time is the input, and at the start, that would be 0 seconds. So 0 seconds equals the input, and it's 25 feet, while feet is my output. So 25 feet equals my output. So when I write this, that means R for the rocket at 0 seconds equals 25 feet. And we can see that at the vertical intercept right here where I put the blue point. If you have any questions about this practice problem, about how to take the descriptions and turn them into function notation, please leave a comment below and I'll get back to you with further clarification. Our next practice problem, A of T, is the average high temperature in Aspen, Colorado, T months after the start of the year. M of T is the average high temperature in Minneapolis, Minnesota, T months after the start of the year. The temperature is measured in degrees Fahrenheit. Which function had the highest average rate of change between the beginning of January and the middle of March? What does this mean about the temperature in the two cities? So if we look, we are comparing from the very beginning of this chart, where the origin is going to be the beginning of January, until the middle of March. Well, the middle of March appears to happen right about here where the two lines meet. So at mid-March, they have reached the same temperature. But when we're comparing how much they've changed, Aspen has only gone from about 35 to about 48, while Minneapolis has gone from about 25 up to about 48. So if we're looking at these, then Minneapolis increases, let's say, 23 degrees. In the same time, Aspen only increases, looks like about 13 degrees. So because Minneapolis increases more in the same amount of time, M of T had the higher rate of change. Then they want to know what this means about the temperature in the two cities. And what this means is that Minneapolis winter temperatures change more than Aspen winter temperatures. So you could do the math to find the rates of change and then compare them, but you can also do it by logically interpreting the graph. If both functions meet at the same point in mid-March, but one had to climb higher to get there, then the one that had to climb more had to have the faster rate of change. We also see that in that time frame, the blue line is flatter and the red line is steeper. The steeper the line, the faster the rate of change. The flatter the line, the slower the rate of change. If you have any questions about how to answer a practice problem like this, please drop a comment below and I'll get back to you with any clarification I can offer. Our next practice problem. Here are two graphs representing functions f, that's the black parabola that opens upward, and g, the green parabola that opens downward. Select all statements that are true about functions f and g. So A says that f of 0 is greater than g of 0. Well, f of 0 means the y value when x is 0. And we see that point right down here at the origin. So f of 0 equals 0. Now g of 0 is the y value of g when x is 0, and we see that up here at about 14. So g of 0 equals 14. So 0 is not greater than 14, so that means A is not a correct answer. Choice B. There are two values of x where f of x equals g of x. And what we need to know is that functions are equal where they meet. And we see that happen right here at this red point, and again here at this red point. So B is true. There are two values of x where f of x equals g of x. Choice C. F of negative 1 is less than g of negative 1. So if I want f of negative 1, I go to where x is negative 1, and I find that y value, which looks to be approximately 1. Now, if I want g of negative 1, I go to where x is negative 1, I go up to where I hit the line, and that y value is about 11. So this one says that 1 is less than 11. That is true, so C is also a correct answer. And finally, choice D, we have f of negative 3. That means we need to go to negative 3 for the x, go up until we hit the black line, and we see that that value is approximately 9. Then we're comparing that to g of 4. So I need to go right until x equals 4, and then I need to go up until I hit g, and I see that that value is approximately 6. So I'm comparing 9 and 6, and it is true that 9 is greater than 6. So D is also a correct answer. So the only option here that was not true was option A. If you have any questions about how to interpret a graph to answer questions about inequalities, please drop a comment below and I'll get back to you with any clarification that you need. Our last practice problem. The three graphs represent the progress of 3 runners in a 400-meter race. The solid line represents runner A, the dotted line represents runner B, and the dashed line represents runner C. Number 1. One runner ran at a constant rate throughout the race. Which one? What you need to understand is that a constant rate is going to be a straight line. So, constant rate equals straight line. And we see that when we look at this dashed line, where it goes straight the whole time, and the dashed line represents runner C. So that means the answer to number 1 is runner C. Number 2. A second runner stopped running for a while. Which one, and during which interval of time did that happen? So, if they stopped running, that's going to mean a flat line. And we see that happen with this solid line between right here and right about here. So the solid line we're going to make yellow, and the solid line represents runner A. So for number 2, this is runner A, and the interval is between approximately, we will say, maybe 15 seconds until approximately 42 seconds. Number 3. Describe the third runner's race. Be as specific as possible. So this third runner is going to be the dotted line. And we see that they run at a constant rate until about 28 seconds. So I'm going to put this down here. Runner B ran at a constant rate for approximately just under 30 seconds, maybe 29 seconds. Then we see that the line starts to curve and flatten out, and that flattening out means the runner is slowing down. So the runner then begins slowing down until they finish, and they finish just before 50 seconds, so maybe 48 seconds. Until they finish at approximately 48 seconds. And then number 4, who won the race? Explain how you know. Well, the winner is going to be the runner whose line finishes furthest to the left, because they will take the least amount of time. So if we are comparing that, we have runner C at about 39 seconds. We have runner B at about 48 seconds. And we have runner A at about 54 seconds. So we would say runner C won because 39 seconds is the fastest. So if you have any questions about any of the practice problems that we went over here in Lesson 9, please leave a comment below and I will get back to you with any clarification that you need. I ask that you please hit the subscribe button so that you'll get notified anytime I add new videos. Give this video a thumbs up if you felt that it was helpful to you, and I look forward to seeing you in the next lesson.